right, 1.3 graphing linear equations. We're going to start with an example. This is all review. We're going to graph the line 3x minus y minus 2 equals 0 using x and y intercepts. So how do we find an x-intercept? Yes.
Don't you set y as 0?
That's exactly right. Set y equal to 0 and solve for x. So y is 0, so we have 3x minus 2 left over. Solving for x, we get x equals 2 thirds. We want to write that as a point. So 2 thirds comma 0. We don't have a scale, so I'll just put 1 here. There's our 2 thirds. 0. So how do we find the y-intercept then? Correct. Set x equal to 0, solve for y. Put 0 in for x, we get negative y minus 2 equals 0. So negative y equals 2. Y equals negative 2. So we get the point 0, negative 2. Once you have 2 points, you can connect it up with a straight line. You have the graph. So, like I said, let's review. Graphing a line, x and y intercepts. Any questions? All right, let's talk about slope. Slope is rise over run. It's a ratio of two numbers. Rise over the run. If you were given 2 points, you can use this formula. Y sub 2 minus y sub 1. Y deals with verticals, right? Y-axis is your vertical axis, so that's basically figuring out your rise. X sub 2 minus x sub 1 is the difference between the horizontals, the x's. That's your run. So you got your rise over your run. Let's apply the formula to this example. Find the slope of the line connecting the points. 1900, 37.5, and 1994, 2.5. These points could come from any data. When you have years involved, that could be talking about anything. That could be talking about sales of something. Could be talking about population of something. This is very realistic points. So let's plug them in. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. What's going to go where? Good.
It would be 3.5 minus 37.5 over 1994 minus 1900.
Yep, that's fine. Could I write it this way? What did I do different? One more time. Well, I switched the points more or less. See, when we did the 2.5 first, we were saying that this was the second point, okay, and this was the first point. Well, what if we decided this was the second point, and that was the first point? That's fine. Just make sure you keep the same order. Okay, so let's put this into the calculator. I think I had it. There you go.
Wouldn't it be negative 35 over 94?
That is correct. But calculator, it's probably going to give you a decimal first if you're using graphing. Then you hit second. Anybody remember? Math? Nope, just math. Okay, math button. And number one will give you a fraction, and it'll turn it into a fraction for you. You were right, negative 35 over 94. That's the slope. The rise, or in this case the drop, vertical drop of negative 35 and a horizontal run of 94. So go down, right. Slope down from left to right. Any questions on slope? Well, then let's talk about slope-intercept form. Again, should be review. You should have seen this formula before. Y equals mx plus b. M is the slope, and b is the y-intercept. Probably the easiest way to graph a line. Although x and y intercepts, which we did the first, works out very nicely as well, especially when you have decimals involved, like decimals and fractions. Decimals are not that easy to plot. If you're worried about how far up and how far left to go, or right. So we're going to graph using slope-intercept form. 2x plus y equals 5. What do we need to do to graph this? Solve for y. So y equals negative 2x plus 5. Just going to move the 2x over. We need to get y by itself. So what do these numbers tell us? Yes. Okay. Or I like to think of it as always a fraction, even if there is an understood 1. That way I know the rise and the run. What's that 5 tell us? Y-intercept and also our starting point. That's where we want to start. So let's plot that first. Y-intercept is 5. Okay. And let's label it as a point. 0, 5. Now we're going to use a slope of negative 2 over 1, so we're going to go down 2, right 1. Once you have 2 points, you can draw a line. If you wish to have a third point, you can do that. Instead of going down 2 and right 1, we can write the slope as 2 over negative 1, which means we could go up 2 and left 1. Usually 2 is enough, but if you want 3, that's fine too. Any questions on slope-intercept form? All right. And we'll talk about zeros of a function. Don't make it complicated. Zeros of a function is just simply another way of stating the x-intercepts. Okay, the x-intercept is a point. If you talk about just the x-coordinate of the x-intercept, we're talking about the 0 of a function. So here's an example. Find the zeros of the function f of x equal to 5x plus 4. Okay, we need to find the x-intercepts, right? How do you find an x-intercept again? Set y equal to 0. I don't see a y. Is there a y? Okay, because in function notation, f of x represents what? Y. So you can, we're going to make the f of x equals 0, or rewrite it as y first, and then you can just say, I'm going to set y equals 0. Same thing. Either way, 0 equals 5x plus 4. Solving for x, we get x equals negative 4 fifths. So that is the 0, negative 4 fifths, which also tells us that we have an x-intercept of negative 4 fifths 0. The point is the x-intercept. The x value is the 0. Any questions on the zeros of a function? Okay, since there's no questions, that's all for today.